This is Algebra 2, Lesson 4.1, Solving Linear Systems with Graphs and Tables. So we're going to start by doing some graphs here. And we're going to graph these linear equations using our mx plus b knowledge that we got last chapter. So we know that there we go. We know that y equals mx plus b is our intercept form, and that b is our y-intercept. And that m would be our slope. And slope is given to us in rise over run. So if I have my y equals 4/3 x minus 2, my intercept is going to be -2. That's my b, my lone number. And that my slope is going to be 4/3. And that's rise over run. So we're going to go rise 4, which means up 4, and run 3, which means to the right 3. I'm going to scroll down so that I can see my whole coordinate grid here. There we go. So my b is -2, and let's go red with that one. That means I'm going to start at -2 on my y-axis. And then I'm going to rise 4 and run 3. So from that mark, 1, 2, 3, 4 up, and 1, 2, 3 to the right. Now if there was more graph here, I could do another 1, 2, 3, 4, 1, 2, 3. Or I could even go this way, 1, 2, 3, 4, 1, 2, 3. But I can do as many points as I need to draw a straight line that covers my whole grid here. So let's do another one with the second equation here. My b in this case is actually 3. So the b doesn't have to be the last number there. It has to be the number without the x, the lone number. And my m here is going to be -1/3 because I have the minus there, which means I'm going to go down 1 and I'm going to go right 3. So starting at b is +3 on my y-axis, I'm going to go down 1 and right 3, and actually landed where I started before. Down 1, right 3, there'd be another dot over here. I can go up 1, backwards 3, there'd be another dot here. Draw as many dots as you need to make sure that you get a pretty straight line. Now the point of this, solving systems by graphing, is to see where those lines intersect. So you can see right here, let's try using my highlighter, that I have an intersection point, and that would be the coordinates are 1, 2, 3 to the right, and 2 up. So if I'm 3 to the right and 2 up, that means the x coordinate of my intersection is 3, and the y coordinate of my intersection is 2. Okay, I'm going to do one more, some equations with a little tricks to them. My first equation here is y equals 3x. So if I want my intercept and my slope here, I only have one number. I have a number with an x, so that tells me that my slope is 3. Since I don't have an intercept, my intercept is 0. And I like my slopes in fraction form because it's a lot easier for me to tell my rise and my run. So anytime there's no denominator, that would be over the invisible 1. So I'm rising 3, and I'm going to the right 1. So starting at my intercept of 0 on my y-axis, I'm then going to rise 3 and run 1. And if I had a little more graph, I could do another point there, or I could go down 3, backwards 1, just so that I get enough points that I can draw a pretty straight line through my grid. Okay, we're going to do the same thing with the second equation here. My m in this case, there's no number in front of my x, that's an invisible 1. And I'm going to put it over 1, so I have my rise and my run. And my b for this one is going to be 2. So this means I'm going to rise 1, run 1, starting at 2 on the y-axis. So here's 2 on my y-axis, rise 1, run 1. And again, I can do as many points as I need to so that I have a clear view of where that line should go. But ultimately, all I'm trying to see is where those lines cross. And I can see them crossing right here, if my lines were a little straighter, at 3, 1. So the x-coordinate of the intersection is 1, and then the y-coordinate of the intersection would be 3. Okay, that's solving equations if we have intercept forms and graphs. We're going to do some solving of systems if we're starting with tables instead. And I got 2 different ways to do this. I'm going to show you both methods, one on each of the equations. So the first equation here is y equals 3/4 x minus 1. I have a bunch of different x values. We're just going to sub each x value into the equation and then record the answers in the table. So if I substitute in 0, 3/4 times 0 minus 1, I can use my calculator if I need to, or my handy dandy brain power tells me 3/4 times 0 is 0. 0 take away 1 is -1. Now, I could keep rewriting these, but I'm going to kind of cheat a little bit here and just erase that out. All I'm going to do is keep subbing in the different values in my x column. So if I put in a 1 then, that's going to be -0.25. And then I'm going to do the same thing where I'm going to sub in a 2. I just keep subbing in all the different values on my x list. 3/4 times 2 minus 1 would be positive 0.5. Now if I sub in a 3, that's going to be 1.25. And again, sub in a 4, sub in a 5, sub in a 6. And as we keep subbing in our different values, it finds us the values on that list. Okay, so I'm going to now show you a different way that we can generate these values for my second y equation. Now this one's going to actually use the mx plus b, because if I know mx plus b, I know that I'm starting at -2 and I'm changing by adding 1 every time. So that works wherever I see my 0 value. I'm starting at -2, and to change I just keep adding 1. Now I like this method with easy slopes because it's really easy to add 1, add 1, add 1, add 1. With the last equation that I wrote in the blue, it's not that bad to add 3/4, add 3/4, add 3/4, but adding 1 is definitely a lot easier than having to sub in 1, sub in 2, sub in 3, sub in 4. Anyways, once we have our tables for both equations written out, what we're looking for now is where our y's match. So if you look here, I have a 2 and a 2 in my 2 different y columns. That's telling me that the solution where these lines would intersect is where x is 4, y would be 2. So if we were to sub 4 into both of these x's of these 2 equations, the answers for y's for both equations will come out to be 2. Okay, that's it for the notes on this lesson. Good luck with the exercises, and please let me know if you have any questions.